Okay, the other thing I wanted to mention was if you haven't looked at your grades lately, I did update over the weekend. And so I didn't put your quizzes in yet. It is graded on Google Classroom, they're graded, but I didn't put it in your Power School grade yet. You will notice on Power School that there was a category, an assignment on there that said like bell work for the week. So before, if you remember, we did those daily logs where I gave you points for your daily logs, following along, doing the bell work, doing our practice problems, etc. So since we're doing decimals now and we converted to decimals, what I've done is I've taken, so for the week, you are getting points for doing your bell work and you are getting points for doing the practice problems like we had been doing before. So if you notice that your grade may not have been great on that one, that's because maybe you didn't follow along, maybe you didn't do the bell work, or you weren't doing like the practice problems in your decimals activity. So if that is the case, and you want to get points back on that, you are more than welcome to. But I'm not going to be able to see that because it's not like you resubmit it. So if you want to get points back, email me and say, hey, my bell work for this week wasn't very good. My participation for this week, what can I go back and do? So if you want to do that, let me know and I can tell you more specifically like, hey, you didn't do this bell work or you didn't do this bell work. I have a little chart that I'm keeping with all of your stuff on it. So if you need further help with that, just let me know. Okay. So let's go back to, let's talk about the homework, which I did. The homework was this page here out of your, I know you can't see your learning packet, page number 6. It was the front. And I looked at your homework. You guys did a really good job for me just saying, hey, try this and see how you did. So this is a start for what our life is going to be in linear programming. So you guys did a really good job. Do check. I didn't grade them yet, but I did go into your assignments and I made comments. So if you did it correctly, I commented on that page and said, great or nice job. If you didn't do it correctly, like maybe your vertice was just a little bit off, I tried to help you with that. So I didn't grade it yet. So after today, if you're like, oh, now I know what I was supposed to do, if you want to go back and fix it, go back and fix it. I won't grade it until, maybe like Thursday. All right. Now, onto our life. Let me share our screen and go to our decimals. All right, so this first one, I'm going to open up this screen. This screen is not in your, let me get to the student account. Okay, so this screen is not in your learning packet that you have because I wanted to give you a little introduction on what the heck is linear programming. So you don't have to necessarily write this down. You can jot this off to the side if you want to. I'm not going to quiz you on this or test you on it, but I just wanted to give you some background on what is linear programming. So I had mentioned before that this is actually a real life thing. Now we're doing a very, very small, like basic problem application, but people that have really big businesses like McDonald's or even just simple like hair cutting places, if they're smart, if they've done their research and they're business majors, they know that they can do these math formulas and find out what should I do in order to make the most money. And so that's what linear programming is. So I put down here, it's a mathematical method to achieve the best outcome. So for example, if you have like a business, you want to see how can I make the most profit? Sometimes you think, well, I should sell more items. True, but what should you price those items at? Because you don't want to price something too high and then no one wants to buy your product, but then you don't want to price it too low and then you lose money on making the product. So linear programming helps you decide what should I charge and what is going to make me the most money. Or, for example, another way is the lowest cost to produce an item. So let's say that, let's say you're in the food industry and you own a pizza business. So all those ingredients that you put into a pizza, you have to think about how much did it cost for me to make the pizza and how much should I charge people? And so you can run these formulas to figure out what is the lowest cost of all these ingredients that can maximize my profit for every pizza that I sell. So it's crazy how people just go into things blindly and like, oh, but if I do a math equation, I could really, really, really make some money. So anywho, moving along. So what linear programming is a set of equations or inequalities. So if you look at this picture here, you'll notice that it's exactly what I had you guys do for homework. You graphed 3 lines, and then you had a triangle here that was your, like here, this is where all of the lines intersected at these 3 points. So this is just an example. This is not like exactly like your homework. But what I had you do was find those 3 vertices. Those 3 vertices are going to be what's important to find the best and maximum value. Okay, so you've already done some of the hard work. Today, we're going to see 2 steps. We're going to see, okay, well, how do I find my maximum profit then? And then the second will be, what if I have a word problem and I have to start from scratch? Okay, so I do apologize. Today is not the most fun day ever in life in math, because I'm going to have to do a lot of talking to work through these problems with you. However, Thursday and Friday will be more of you getting to practice and more feedback back and forth once you understand the whole big picture and big process. Okay, let's move on. Now, the next slide here, slide number 3, is from your learning packet or the course packet that I gave you. So at the bottom, it says page 7. It's in the inequality unit, page 7. So I'm going to, on my screen, I'm going to fill in these blanks. So we're looking at the top section. I'm going to fill in the blanks so you can fill in the blanks on your own paper. That way you don't have to, you have it in front of you. So we're going to start with a little vocabulary and a little definitions in order to help us understand linear programming. All right. So the first box here says the graph of a system of inequalities. In the graph, the lines are called the constraints. So the first, change the color here. The first blank is lines. So those are called the constraints of your linear programming problems, are the lines, the ones that you drew. Okay, the next vocabulary word is feasible region. So I'm going to draw here just an example. So let's say you had those 3 lines and they intersected at these 3 points. This triangle that it created, that is called your feasible region. So that means that any combination of products in that triangle will make you money. That's what that means. Or any points within there are going to be the best options to make you money. So this is your feasible region right there, any triangle that's made. Okay, next, when the graph of a system of constraints is a polygonal region. So I don't know if you remember what polygonal means, but polygonal means any type of shape, a triangle, a square, a rectangle, a trapezoid, a pentagon, whatever. A polygon is any type of shape. So when the graph makes a shape, it's called bounded. Okay, we'll talk about unbounded in a second, but this is called bounded right here because the lines form a shape. All right, next. Okay, the maximum or minimum value of a related function always occurs at one of the vertices on the feasible region. So that's why I had you find those points, because one of those points that you found is going to maximize your profit, like make you the most money. All right, moving along. Next line, we're almost done. We got 2 more lines to fill in. So the next line says, when a system of inequalities forms a region that is open, the region is said to be unbounded. So this is what an unbounded region would look like. Let me draw it for you. Nope, I wanted to draw, not a text. So an unbounded region would be something like this. You would have parallel lines. So if your 3 lines did this and did not form a shape, and I know this should look familiar in geometry, right? This is parallel lines with a transversal. This is called unbounded. Okay, we aren't really going to work with this too much, but I just wanted to identify to you that that could happen. If that happens, there is no maximum profit here. It means that there is no solution to this situation. There is like maybe once within the next 3 days, we'll see something like this, but it's not going to happen often, but just wanted to show you what a no solution would look like. Okay, lastly, the process of finding the maximum or the minimum values of a function for a region, that's a lot of words, defined by inequalities is called linear programming. So that's what we just talked about. So this whole process we're about to go through of finding your maximum profit is called linear programming. Okay, now I wanted to go over this vocabulary because you're going to have a small vocabulary homework assignment for tonight, just to continue to get familiar with these terms for today. Okay, let me know. I want to make sure before I go on to the next slide, let me know that you have all this down. Either give me a thumbs up or you can type, I'm good to go. Yes, I got it all down. Make sure you have this all down before we move on to our next example. Does anyone need more time? Holler at me, shout out, chat me. Does anybody need more time? Anyone in the house? Hopefully you're still with me. All right, we're going to keep it moving since nobody said anything. Let's go on. So now I'm just going to the bottom of the page. I split it up so I could see better and that it wasn't so small on the screen. Okay, so let me go to the next slide. So I'm on slide 4, which is the bottom of page 7, which also says at the bottom, it says page 60. I tried to be very clear with that. Okay, so this here is what you did for homework. Okay, this is a new example, but I'm not going to go through this in depth, but I'm going to show you the next step with graphing. So once you graph these inequalities and you find the 3 corners. So just to go through this again, I'll show you. So this one I'll do or just show you in blue. So your X1 is at 5. That's right here. Oh, nope, I lied. Back that truck up. Okay, here's your X at 5. Okay, your Y equation we'll do in orange here just so you can see where these are coming from. So I'm not going to go over how to graph these. You already know how to do this. I'm just going through this quickly. The purple one is our angled one here. So you have to be very, very, very precise on your lines. So some of you on the homework, your lines were a little crooked. That's okay. But as you're plotting the slope, just see how I'm putting these dots on here? Just keep plotting the slope until the lines intersect. Otherwise, you may get the wrong coordinate point where they intersect at. And we have to be very precise. If it's too difficult to do it on Desmos, just do it on your own paper and you can take a picture. So down at the bottom here, this is what we already did for homework. This is what I'd asked you to do. So if you didn't do the homework and you weren't sure what to do, this is what you're doing. You graph the lines and then you find those 3 vertices. So the 3 vertices showing, get back to the mouse here. The 3 vertices are these 3 corners right here of the triangle. So that was on your bell work, which everybody did a good job of reading my notes. The vertices are the corners of the triangle. So down at the bottom here in your paper, you're just going to write in those vertices in any order, it doesn't matter. So you have -2 and 4. We have 5 and -3. And then lastly, 5, +4. Okay, so those are the 3 points that we are going to test. Okay, we're going to test those to see which of those combinations are going to make us a profit, or what is going to maximize our objective. So if you notice in our word problem, we have another, look at this, we have another equation right here, this function equation. This right here is what we would call either, let me type this in, it's easier if I type it in. So this is either your objective function, or sometimes it's called a profit function. It all depends on what you're looking for. Like sometimes your objective might not be to find the profit. It might be to find how much of something you want to use. So instead of money, it could be, how many pounds of flour do I need, or how many pounds of cheese do I need? So it might not necessarily be money, but it's going to be what is going to maximize. So that is what that is called. That's what we need to answer our final question here. So we want to figure out what we're going to use. Okay, let me move on to the next screen. Hopefully you got that down. So I'm going to open it up. We're on slide 5 now, which is also going to take us to the back of that page. So now we're going to be on the back of page 7. It says page 61 at the bottom. Okay, let me move into that. So page 61 at the bottom, I'm sorry, 61 at the top, there's a chart up there. So now what we're going to do is we are going to use those 3 points. So you'll notice right here, these are the 3 points from the other side. These are the 3 points that we identified from our triangle. Now we're going to take those 3 points and we're going to plug them into our, remember this was our objective function, AKA our profit function, or whatever it might be. We're going to take these 3 points, we're going to plug it in, and we're going to figure out what is our value of at that point. So for example, let me show you the first one. Put a text box here. So you would type in 3 times -2 minus 2 times 4, or you would write that in. So you are basically just doing a substitution to check what is the value at those 2 points at our objective function. So 3 times -2 gives me -6, and then -6 minus 8 is going to give me -14. So you would put -14 in the box in the right-hand column. All right, everyone okay so far? Stop me, holler at me if you're like, I don't know what in the hizzle you are doing right now. Okay, let's keep moving then. So we got the next one, plugging in 5, -3, so it'll be 3, come back. 3 times -5 minus -3, wait, 2 minus 2 times -3. So this will be, wait, it's not -5, I'm sorry. 3 times 5 minus 2 times -3. So this will be 15 plus, because that'll turn into a plus, -2 times -3, 6. 15 plus 6 is going to give me a 21. Okay, and then last but not least, plugging in this function, let's change this to blue, text box here, new text box. All right, the last one plug in will be 3 times 5 minus 2 times 4. So 3 times 5 is 15, minus 8 is going to give me 7. Okay, so that is the next and final step after we identify the vertices. So again, for homework, you identified the vertices. The next step would be to take those vertices and plug them into whatever function they give you. And we are trying to find now where is the minimum and maximum value. As you can see, they already identified them for you. We have our minimum and maximum right here. So we're going to fill in the blanks right here. So the vertices of the feasible region are, we already said that. Let's skip this. We already know what those are. This is the important part. The maximum value is 21. 21 was your maximum value at 5, -3. So this is just analyzing your data. So my maximum value is 21 at the coordinate point 5, -3. My minimum value is -14 at the coordinate point -2, 4. Okay. So that is the last and final step in my process. Okay. If you have no questions, or if you're feeling okay so far, what we're going to do, I'm going to open up, this will be some time for me to stop talking and you to practice. I'm going to open up slide number, what slide are we on now? Move. slide number 6. So slide number 6, I'm going to open up to you, which is you are going to do just letter A. So at the bottom of the page that you're on, you are just going to do letter A, where it says your turn at the bottom. And so you can graph right on there, or you can graph in here. It doesn't matter. And what I'll be looking for is on this page, I just want you to tell me where is the minimum and where is the maximum. Okay, minimum and maximum is what we are looking for. Okay, I'm going to give you a few minutes, like 5 minutes. It shouldn't take you too long to graph these because it's pretty much solved already. So we are just practicing what you are supposed to be doing, making that chart. So you're going to graph. You will find those 3 vertices, and then you're going to plug those 3 vertices into this objective function at the bottom. Okay, just doing letter A, just letter A. All right, I'll give you about 5 minutes. Go ahead and work on that, and I will come give you help as you need it. Exactly how to solve and set up this problem, because again, you will see this on your homework this evening. Okay, let me clear my, let's see, I can erase this, right? Erase, there we go. Okay, so we had some good questions in the chat that not everybody shared, but one of the questions was, where do I plug in my numbers? Like, do I use the 2 or the 3x minus 2y that we did at the top? Nope, they give you a new one every time. So right here, you can see this is your function that you would plug in once you find your 3 points. You're going to use this function right here. Okay, so let's do a quick little graph here. So x is less than or equal to 4. So one thing to note, you don't have to worry about shading with this anymore. So don't worry about the shading, just graph the lines. The important thing is, where do they intersect? So x is less than 4, we would go to where x is 4, and then I saw a lot of you making these nice points, so that was good. So that way you knew exactly where it needed to go. Okay, you can also use this line function to try to connect them together to make it as straight as possible. Okay, I'll do the next one in Poiple. So y is less than 5, so we'll go 1, 2, 3, 4, 5. Also, so it's important to put those points there because, see, that's going to be one of your intersection points right there. Okay, so go ahead and put that. And then lastly, make sure that you subtract that x over. So you should have y is less than or equal to, wow, that's a mess. You should have y is less than or equal to negative x. Let me do a different color. So it should be negative x plus 6. So you would go to the 6, 1, 2, 3, 4, 5, 6, and then you would go down 1 over 1. And so again, I think it's really helpful to go ahead and plot those every single dot, just so you can see exactly where they're intersecting. Otherwise, you could be off by a point. Okay. So here's I saw some of you guys shading this in. That's great. That's our feasible region. Remember in here, that's our feasible region. But with the important part here are 3 vertices, which I will put in black, are there, there, and there. So these 3 points are where they intersect. Okay, so those 3 points are going to be at, if you did it correctly, exactly, you have one at 1, 5. You have another one at 4, 5. And then your last one is at 4, 2. Okay, so all of what I've done so far is exactly what your homework was like. So if you didn't get it on your homework for today, go back and you can fix it. This last part is our new part for today. So our new part is, which one of these 3 points are going to be the maximum and the minimum values? So we have to take these 3 points and we are going to plug it into this function up here, the one that they gave us. So they're going to give you a new one every time. So when I plug in the 1, 5, that's going to be 4 times 1. So 4 times 1 minus 3 times 5. and that's going to give me a negative 11. Okay, so that's one of my values is negative 11. Next, 4 and 5. So 4 times 4 minus 3 times 5. And that is going to give me 1 because that'll be 16 minus 15, and that'll give me a 1. And then the last one will be 4 times 4 minus 3 times 2, which 4 times 4 is 16 minus 6 is going to give me a positive 10. Okay, so then after this, you're going to identify, and all you have to do is really just circle and label if you want. So this one, that's our lowest value is negative 11. So that's going to be our minimum value. And then positive 10 is going to be our maximum value. And that is it. That is it. Okay. We're going to stop here for today. We did not get as far as I wanted to, and that is absolutely okay. But I need to adjust your homework because half of the homework you are okay, but the other half we're not okay to do. So what I'm going to do within the next 10 minutes is I'm going to make a new homework assignment. It will be in your Google Classroom by the time you're done with second block. Okay. So I will make a new homework assignment. I'll put in there, it'll say adjusted homework or whatever I put in there. So it will not be on this Desmos assignment. Okay. I'm going to make a new one that is adjusted because of how far we got, which is absolutely fine. I'm okay with it. Okay. If you don't have any questions, you are free to go and have a great day. I will see you on Thursday. If you have any questions, you can stay back and I can help you with anything that you need.